Hi guys. So we are going to be doing some problems that relate to Boyle's law. And Boyle's law, we study the relationship of pressure and volume. As you increase the pressure, the volume decreases, and as you decrease the pressure, the volume increases. And a typical apparatus is a cylinder which holds the gas, and there is a movable piston. So the movable piston can be moved up and down, and as you bring the piston down, the volume is going to decrease, and you can read the pressure reading in the regulator on the side. Generally, the pressure readings are in atmosphere or in millimeters of mercury or in PSI. Okay. Next, if you bring the piston up, similarly, you're going to see that the gas inside the cylinder now expands because there is more volume. So in this problem now, we are going to find out that in the first case, you are given when the pressure is 4 atmosphere, then the volume at that time is 6 liters. And now you move the piston up and you can see that the gas, the same amount of gas is now occupying a larger space. So the volume has increased, but because this piston has moved up, there is less pressure. So the pressure in the second scenario is 1.0. So now the question is asking you to what is the volume of the cylinder if the applied pressure is decreased to 1 atm. So how are you going to do this problem? You are going to first write down all that is given to you. You are given the values of pressure, which is going to be your P1 in the first case and the volume in the first case. So the pressure in the first case was 4.0 atm. And at that time, the volume is 6.0 liters. Okay, then you have a pressure 2, which is 1 atm, 1.0 atm. And here you want to find the volume in liters. Okay, now always for the gas laws, you should always write the formula. So we know the formula is P1 V1 is equal to P2 V2. And in this case, we need to find a V2. So when you do the algebraic conversions, you are going to get P1 V1 over P2 is equal to V2. And now you just plug in the numbers and just make sure one thing, that the units are the same on both the sides. And if the units are not the same, then you have to change at one side, whichever side you decide to, it doesn't matter. Okay, so just plug in the numbers, which is pressure is 4 atm, so 4.0 atm multiply by volume V1, and that volume is 6.0 liters, divided by P2, and that P2 is 1.0 atm. So you're going to see that the atm and the atm cancel out, and you're only left with the units of liters. So 4.0 times 6.0 divided by 1.0, and here you're going to get 24 liters. So that is the value of V2. Okay, so this is one example, and let's look at it another example in which we are given another example is, let's say this is example number 2, and here you are given the pressure 1, volume 1, and you are given the value of pressure 1 is 765 millimeters of mercury. Okay, and you are given the volume, in this case 1.78 liters. You are also given the volume 2, which is 1.25 liters. So as you can see that clearly here it's 1.78, and here the volume has been lowered. The volume has decreased. So that means the pressure should increase or should be more than 765 milliliters of mercury. So now we are going to find out the setup, which is for P2. So P1, V1 is equal to P2, V2, P1 over V1 over, or P1 times V1 over V2 is equal to P2. And now you just plug in the numbers, which is 765 millimeters of mercury times V1 is 1.78 liters over 1.25 liters. And so with that, you can see that the liters and liters cancel out, and you're only left with the units of millimeters of mercury. So 765 times 1.78 divided by 1.25 gives you 1.09 into 10 to the power 3 millimeters of mercury. Okay, 1.09 into 10 to the power 3 millimeters of mercury. So this is the way you can find the pressure. Now, if the question asks you, like, convert it into liters or convert the liters to milliliters, so similarly, you have to do those conversions, or millimeters to atmosphere. Similarly, you will have to do those conversions. Okay, so I hope this was easy, and thank you for watching.